to talk about solving systems of equations by elimination. We've talked about graphing. When we solve a system of equations by graphing, it's where the two graphs cross. There's a point, and that point is our xy that satisfies both equations. So it's true for both. We've done solving by substitution, where we solve for one of the variables, for example y, and then plug that into the other equation so that we have just one variable to solve for. And we can solve for one of the variables and then go back and take the information that we've learned and solve for the other variable. By elimination, we're going to use it kind of simplifies and quickens things a little bit. What we're doing is we're going to put our equations together. Remember, with equations, we can do anything to them as long as we do them to both sides. So I'm going to go through one example, and then I'm going to give you another example that I would like you to try on your own, and then you can watch the solution on the video as well. Okay, so let's go ahead and start with this first one. So I have x plus y equals 7 and 2x minus y equals 2. Okay, so what I see is that I have a positive y in this one and a negative y in this one. And those are opposites, so they could cancel each other out. So what I want to do is I'm actually just going to add these two equations together. Okay, so I have x plus 2x, that's 3x, and y plus negative y is 0. So those cancel each other out. And then I have 7 plus 2, which equals 9. So 3x equals 9, divide both sides by 3, and x equals 3. Now that I know that, I can go back and plug this back in, and 3 plus y equals 7. Subtract 3 from both sides, and y equals 4. So my answer to this one would be 3, 4. Okay, so the things to remember when doing this is that you can do anything to these equations to manipulate them as long as you do it to both sides. Okay, so I'm going to give you another one to try, and then I'll go through it. Just a couple of other little things. Right here, I could subtract instead of adding. So if they were the same, if it was y and y, I could subtract, and then I could still get it. I can manipulate this, so I can multiply everything in the top equation by 2 and then combine them as well. Okay, so those are just some strategies, and we'll do some more examples. I'll finish this one. I'll have you do this one, and then we will I'll do another video for examples. Okay, so the example I'd like you to do is 2x minus 4y equals 2, and negative x plus 4y equals 3. Okay, go ahead and pause the video, try that out on your own, and then when you're done, unpause the video and I'll show you the solution. Hopefully they match. If they don't, then hopefully you see what's different, why it didn't work. Okay, so we have a negative 4y and a positive 4y. Those are going to cancel each other out if we add them. If I were to subtract them, I'd end up with negative 8y, and that doesn't really get us anywhere. So I'm going to add them. 2x plus negative x is just x. Negative 4y plus 4y is 0. And 2 plus 3 is 5. That was pretty easy. And then I'm going to plug it into the, it doesn't really matter. I'm going to plug it into the top equation. So I have 2 times 5 minus 4y equals 2. 10 minus 4y equals 2. Subtract 10 from both sides. And those cancel. Negative 4y equals 2 minus 10 is negative 8. Divide both sides by negative 4, and y equals 2. So for this one, my ordered pair would be 5, 2. And so if you were to graph this, that's where the two lines would cross. Or if you were to do, you could also do substitution, and it would come out the same. Okay, so that's it for this video. I will do one more video just with some other examples where we have to multiply or divide or change the equations in some way.